A quick video of the H18 thru-beam variant that I'm using is 11000061. What we're going to be doing is trying to figure out splice detection. I'm just using this ribbon that I've got here. I've got it hooked up over IO-Link to my PLC, where I'm actually pulling the received light value out of it. When you get the sensor factory, it's going, the process data is going to be QL1 and QL2, but we can change the process data where we get the current receiver value, so the amount of light that we get into the receiver. This will have to be changed over IO-Link with a PLC or SOPIS or with your master. Somehow you've got to change that process data. But I've already changed it on mine. I've got it hooked up to an IO-Link master, and the only thing I did is I brought the IO-Link data in, and then I byte swapped it, and then I just put a comparator here equal to greater than. I'm going to turn on this output whenever it sees a splice or double thickness. So this is the sensor right now, and it sets, that's the received value that I'm bringing in. And if I completely block the beam, you see it goes down to 2. I got a threshold of 1,000. I can change that to whatever I want, and it'll just change it to PLC. So if I take this ribbon and I just put one layer in there, it sees right through it, not a problem. If I double the layers, now you can see the received value has dropped. I put it below 1,000, so it's just splice detected is kind of what I'm looking at. So if I'm looking at double layers, I can detect that. And if I'm looking at a single, then I don't see it. So depending on the material, this may work out great. Just depends on how much light can actually get through the material when there's a splice and when there's not.